Alright, this is the homework for Chapter 5, Section 2. We're going to do number 2 and number 3 first. Looking at this triangle, you need to realize that this piece here and that piece are both congruent. And then we have the 90-degree angle on the side and right here. And then we also know that this side is congruent right there based on the reflexive property. It's congruent to itself. So we'll mark that up. And now, based on side, angle, side, we have two congruent triangles at the top, and same at the bottom, because this is a 90, we have side, then angle, side here, says that the two triangles at the bottom are congruent to each other also. So knowing that, then CP-CTC tells us that all of the parts in the triangles also have to be congruent. So for example, number 2 asks for AB. If AD is 15, the corresponding part with AD would be AB. So AB would also be 15. Okay. Second question asks for BC. BC is this side. It's across from the 90. The side across from 90 in the bottom triangle is the 18 right there. So that means that BC is congruent to BD, and since BD is 18, then BC is also 18. Alright, for number 6, for number 6 we need to find X, JK, and JM. The first thing we need to see in this picture is that JL here, that I'm highlighting, is the angle bisector of angle KLM. Angle KLM. Because that's an angle bisector, that tells me that point J here, point J right there, is on the angle bisector. And what we learned in today's lesson was if it's on the angle bisector, this segment is congruent to that segment. So if they're congruent, we set them equal to each other to solve. Alright, and the other way you would know that JM and JK were congruent, in case you forgot that rule from the lesson, would be right here we have an angle. We have an angle, and the reflexive property tells us this side. So angle, angle, side would also tell us that these triangles are completely congruent. So let's solve for X. We set the two segments equal to each other. We get 2x minus 7 equals x plus 5. Add 7 to both sides. Subtract x from both sides. You get x equals 12. So we got x. Now for JK, we know JK is x plus 5, so we're going to take our 12 and plug it in for x right there. We do 12 plus 5. That would give me 17. So JK is 17. And because we know JK is congruent to JM, that would make JM also 17. Okay, for number 12, we want to see that YW is the, right here, YW that I'm highlighting, is the perpendicular bisector of TZ. So that tells us that W, right here, this point W, is on that same bisector. So from what we learned from today's lesson, that would tell us that this segment is congruent to that segment. The other way you could know that, again, would be side, angle, and then because the reflexive property, side, angle, side would tell you the two triangles are also congruent, which means their parts are congruent. Okay. So if these two pieces here are congruent, then we just set them equal to each other to solve the problem. So to solve for x, you get 2x equals 3x minus 5. Subtract 3x from both sides. We're going to get negative x equals negative 5. So whenever you see a negative x, that's like a negative 1, so we divide both sides by negative 1, and we get x equals 5. So the value of x is 5. And be careful, the length of those sides is not 5. The value of x is 5. You'll use that to help you with the next few problems. Alright, this will be a little bit longer one. This is 18 through 25. So the directions say CD is the perpendicular bisector of both XY and ST. So if I go down to where CD, that I'm highlighting here, where that crosses XY first, I'm going to add a few things in here. I'm going to add right here a 90-degree angle. But it says that tells me it's perpendicular, but I also need to know it's a bisector, so I'm going to mark this and this congruent. So those two segments are congruent. By the way, that means that if XD is 7, DY is 7. We'll actually just fill that in. Number 24 says DY is 7. Okay, and then we also have to put a 90-degree angle at angle M here, because it said ST is also a perpendicular, or CD is the perpendicular bisector of ST, so that also tells me that this segment is congruent to that segment, which means if SM is 5, ST must also be 5. So we'll go over, find ST, that's number 23, that's also 5. So every point that is on the perpendicular bisector is an equal distance from each side. So the first question is, what is CT? Okay, so look at the picture, find CT. CT is going to be congruent to CS on the other side. It's going to be congruent to the CS right there, because these top two triangles are congruent to each other according to side. We got a side there. We'll put 3 dashes. Side, and then the angle M, and the side with 5, that'd be side, angle, side. Okay. Alright, so if I know SC is 12, I know the others, so we know CT is also then 12. Let's go on to TY. TY is the bottom half I'm highlighting right here. Okay. If I know that SC over here is 12, and I know the whole thing is 16, then I would want to do 16 minus 12, which would equal 4. So TY there would be 4. Get rid of some of that mess on the screen. Add that back. TY is 4. And we go to SX. For SX, it's the bottom half. Since TY was 4 right there, that means SX on this side is also 4, since those are congruent triangles. So both the smaller triangle and the bigger triangle are both congruent. So on to CX. Okay, we'll highlight CX here so we can find it. CX would be the full length of this side. Well, the full length of the other side there is 16, so that means that CX would also be 16. Okay, then we're on to MT. MT, oh, we got MT is 5. It looks like we messed up MT and ST, so MT is 5. Let me erase ST. ST would be all the way across that middle line. I'll highlight that. Oops. Let's see, I'll highlight that. That'd be this whole line here. That would be 10. 5 plus 5 is 10. And then last we got number 25 is XY. That would be the full length across the bottom here. And we already marked that XD is 7 and DY is 7, so we add them up to get 14. Okay, number 28 is asking, is point A on the angle bisector? So, in other words, if I drew in an angle bisector right from X right through there, is point A on the angle bisector? We would have to use the converse of the angle bisector theorem, which tells us if a point is on the bisector, then it should be an equal distance from each side. So this point A should be an equal distance side from side XR and XT. But if you look here, the distance, you measure distance perpendicular, is 8 on that side, and it's 9 on that side. So because they're not exactly the same, point A cannot be on the angle bisecting line. So the answer would be no, it is not a bisector.